Hello, ladies and gentlemen. Okay, so in class we introduced the concept of what a piecewise function was, and we practiced evaluating from a graph and also from the given function. Now, in these notes, we're going to be looking at how to graph a piecewise function. It's really important that you take great notes and that you are really paying attention and you're following along on your graphing calculator as we are doing it. Okay, so now we're moving on to graphing a piecewise function. Okay, so this is a big skill and it has been tested on the final exam. So definitely something we need to make sure that we know how to do. The idea here is that, again, you have two different formulas guided by two different intervals. And so we are being told to graph each of these formulas, each of these, in this case, lines, only in the x values that they are telling us to. So this is kind of like the guidelines or the rules. And these, okay, are our formulas that have to follow these rules. So these are kind of some steps that we're going to go through to work through. First thing we have to do is make a table of values for each formula, starting at the given x value and counting up or down according to the interval. Okay, so that first step is really important. We have to take, in each of these formulas gets its own table of values. So if I have two formulas, two tables of values. Okay, x is on the left-hand side for both of them, and then the right-hand side is the formula name. So I have 3x minus 4, and I have 5 minus x. Okay, now what x's are we using? That is where our intervals come into play. It says start at the given x value and count up or down according to the interval. So this is telling me x is less than or equal to 2. So I'm going to start at 2 and I'm going to count down because it's less than or equal to 2. So 1, 0, that's probably enough. These are lines, and so a few points is plenty. Okay, and the other one, I'm going to start with 2 as well. But to this time, it's x is greater than 2, so I'm going to go up. 2, 3, 4. Now, what you might want to do at this point is recognize your open versus closed circles. Okay, so at x is equal to 2, for the first rule, for the 3x minus 4, it's x is less than or equal to 2. So would you have an open or a closed circle? I would say you're going to have a closed circle. Closed because it's less than or equal to. As opposed to the second rule, which is just x is greater than 2, you do not include, and so therefore you have an open circle. So I'm just going to mark that right next to my table so it helps me keep that in mind. The other thing you might want to do is as you go after 0, okay, and after 4, you're going to have arrows because you're going to keep on going. So you might want to just kind of put arrows here to indicate that at the end of that, you're going to have arrows that keeps going, because this is saying all numbers less than 2. There's no minimum. It keeps going. And all numbers bigger than 2 keeps going, no maximum. All right, so here we go. Now, how do we get these values? Well, that's where your graphing calculator comes into play. So you're going to just go to your y equals, every one of you knows how to do this, and type 3x minus 4 into your y equals. So I want everyone to do that and get a table of values. Okay, so the first table of values, when I did it in my calculator and I pulled up my table of values, this, of course, was for the rule 3x minus 4. I typed that into my y equals, I went to my table, and this is the table of values I'm looking at. Now, you want to start with x is 2, and then you want to go backwards. So we want these 3 points to be written down. So I'm going to carefully write those down, that when x is 2, I should have a value of 2. When x is 1, negative 1, and when x is 0, negative 4. Okay, now I'm going to do the same thing for y equals 5 minus x. So I'm going to go to my y equals, clear out the 3x minus 4, put in the 5 minus x. I'd ask that you do the same thing right now. Get a table of values for that one, and then copy down the values specifically that we want for 2, 3, and 4. Okay, so here's my second table that came up. I know it's probably hard to read that, but this is the rule 5 minus x. And again, I'm only taking the values that I want. In this case, the 2, the 3, and the 4. So I'm going to copy those y values down. So when x is 2, y is 3. When x is 3, y is 2. And when x is 4, y is 1. Okay, now I'm going to go one line at a time, and I'm going to plot these points. So I'm going to start, first of all, with the first rule, the 3x minus 4. And I'm just going to plot these 3 points. I'm going to be cognizant or thoughtful of the fact that I should have a closed circle at 2, 2. Okay, and I'm going to end my line with an arrow at 0, negative 4. So I'm going to go 2, 2, so 1, 2, 1, 2, and you should be plotting these points along with me with a closed circle. 1, negative 1, and 0, negative 4. 1, 2. Okay, now I want a closed, it needs to end when x is 2, and it needs to go on forever after the 0, negative 4. So I'm going to draw in my line starting here, and I'm going to continue it like that. So that is the first formula, the 3x minus 4, only graphed when x is less than or equal to 2. Okay? Now I'm going to go on to the second formula, the 5 minus x. Now as I plot this first point, the 2, 3, I need an open circle. So 2, 3 has an open circle. Then I have the point 3, 2. And then I have the point 4, 1. Now, when I connect those, again, I could draw them, and I end up with, an arrow pointing in the direction that it's going. So sorry, I don't have a ruler. This is as neat as it gets, okay? But you have an idea then of what this looks like. So there is my piecewise function. I have an open circle and a closed circle, and I have arrows pointing to the left and to the right, indicating that it's going to continue to go on and on. All right, let's try number 2. Okay, number 2, we're graphing p of x is equal to, this time I have 3 formulas to follow with 3 different intervals. So I have negative x for x is less than negative 1. I have 3 for x between and including negative 1 and 2. And I have negative 1/2 x plus 4 for x is greater than or equal to 2. So if I have 3 rules, I need 3 tables of values. Okay, so I'm going to go ahead and set those up. 1, 2, and 3. Now each of these table of values, I have headings of x on the left-hand column, and then I'm going to use each of my 3 different formulas to head up the right-hand column, the y column. So I have negative x for the first one, 3, and I have negative 1/2 x plus 4. Okay, so those are my different things. Now I'm going to go ahead and write down my intervals. So remember, the way that we do this is we start with that given x value and we count up or down according to the interval. So x is less than negative 1. I'm going to go negative 1 and I'm going to count down. So that would be further to the left, getting smaller and smaller, like negative 2, negative 3, negative 4. Okay? So we have those. The other thing I'm going to do right away so I don't forget is I'm going to put an open circle marker next to negative 1. Why did I do that? Hopefully you agree that that's because you do not have an equal to, it's just less than negative 1. Okay? Now moving on to my next interval, it's between negative 1 and 2. It includes the negative 1 but not the 2. So if this is the case and they are giving us that very specific, then that's all I'm copying down. So I don't keep going. I go negative 1, negative 1, 0, 1, and 2. And I can also think about open and closed circles. The negative 1 is less than or equal to x, so that's going to be a closed circle. Okay, whereas the 2 is just less than, x is less than 2, so that's going to be an open circle. All right, last one. We have negative 1/2 x plus 4, and that's for x is greater than or equal to 2. So I'm starting with my 2, and I'm counting up. So 3 and 4. Okay, and that is going to be closed circle on that 2. And the only other thing I want to do is show that I'm going to have an arrow here at as I continue on to the left of negative 1, and an arrow as I continue on after the 2. So if for x is greater than or equal to 2. And then this middle function is going to have two endpoints, one open and one closed circle, it looks like. All right, so now I need to get a table of values, fill in my table for each of these. So go ahead and go to y equals, fill in your table of values for each of these. So one at a time. I'm just going to ask the sub right now to go ahead and press pause. And so if you could pause the video, let them fill in their table of values. When everyone's ready and has their tables completed, then you can go ahead and start it back up and watch the rest of it. So if you would pause right now. Okay, so hopefully you and I agree on our table of values. Okay, so just check yours over and make sure that we have the same values. That when for the first formula, it's just negative x. So all it did was negate my x's. So I ended up with 1, 2, 3, 4 for my y values. For the second one, my y was equal to 3. And so therefore, all of my y's here are just going to be 3. There's nothing to plug this into. You just get 3 back always. The last one was negative 1/2 x plus 4. And what I noticed, of course, with this one is because you were taking when you took half of an odd number, you got a decimal. So I just went out one more even number to give me another whole number to look at. Okay, so now we have to graph each of these on our graph paper. Okay, so we're going to start with the very first one on the left-hand side, and again, we plot the points, and then we take a look at what we get. All right, so I'm going to start with negative 1, 1, which is an open circle. Okay, and then I go negative 2, positive 2, oops, and then negative 3, 3, and negative 4, 4. And so I can see that I have a line here. Going to continue on. I have an arrow at the end and an open circle there at negative 1, 1. Okay, next is the middle function, and that's negative 1, 3, 0, 3, 1, 3, 2, 3. And so you have this horizontal line at y equals 3. But it starts at negative 1, 3 with a closed circle. So negative 1 up 1, 2, 3 with a closed circle, and it ends at positive 2 with a open circle. And then all of the other ones are just equal to 3. So it should look something like that. Okay, now look at what happens as we move into our third formula. Okay, we ended with the point 2, 3, and we're going to begin with the point 2, 3. Well, let me ask you something. When you have an open circle and you put a closed circle over top of it, it fills it in, and you end up with what? Hopefully you're saying a closed circle. So if you have an open hole and then you are plotting on top of it a closed hole, okay, 2, 3 is a closed circle, what ends up happening is you just have a closed circle. And what happens here is they are gonna intersect. So as I plot these other points, I'm going to plot the point 4, 2 and the point 6, 1. So as I connect those, you can see that the reason why that happened is because where this horizontal line left off is exactly the place where this line picked up. And so you end up there with a closed circle at the point 2, 3. Okay, so that's our second graph. We had 3 different rules, 3 different formulas, but as long as we set them up one table each, it's easy and we can get this done. You just have to take your time to set your tables up and then go to the graph. All right, let's move on to the third one we're going to practice graphing. Okay, number 3, g of x is equal to absolute value of 2x minus 3, and that's for the interval negative 3 less than or equal to x less than 1. And then 5 for when x is between and including 1 and 7. Okay, what you'll notice here is we don't have any open-ended intervals. What do I mean by that? Well, it's not just for all values less than 1. They have a start and a stop to both of these intervals. And that means you're not going to have arrows at all on your graph, okay? Both of these are going to be line segments. The first one, okay, and then the second one, or they're going to have endings, I should say. They're not going to have arrows going on and on. Okay, and so we have to keep in mind open and closed circle now a little bit more than just in the middle, but also at the ends for both of these. All right, so as I take a look at this first one, absolute value of 2x minus 3. Okay, we have to get that in our calculator definitely and enter that in. So when we enter that in, hopefully you remember, so absolute value of 2x minus 3. So when we enter that into our calculator, we have to get those absolute value bars in our calculator. So I'm going to talk you through it. You're going to go ahead, remember, and press math, which is the third button down on the left-hand side. Then you're going to right arrow over to num, and then you're going to hit enter for ABS. So I'll say one more time, math, which is the third button on the left, right arrow over to num, and then the very first choice, you're going to hit enter for ABS. And hopefully the absolute value bars come up. Now you're doing this in the y equals, and you're going to enter the 2x inside the absolute value bars, and then right arrow out of it, and then your minus 3. Okay, and what x values am I filling in on the left-hand part of my table? What values do I look at? Well, hopefully we all agree that's where this interval comes in. And they are being very specific. They want you to look between -3 and +1. So -3, -2, -1, 0, and 1. Okay? And I can even be specific about open or closed circles. I can see that when x is greater than or equal to -3, so that means this is going to be a closed circle. And on the right-hand side, it's x is less than 1, so it's going to be an open circle. Okay, so go ahead and fill in that table of values there. We have the first one written out, and we have the values we need. So go ahead and fill those in, and I will see if I agree with you. Okay, so as I'm looking at my calculator, when x is -3, I have the value 3. When x is -2, I have 1. When x is -1, I have -1. When x is 0, I have -3. And when x is 1, I have -1 again. So that must be where it starts to come back around in its v. Okay, the second function, the second rule, that I have to follow, or formula, when I have x, okay, in the left-hand column, and my y value is simply 5. And what x's am I filling in for this one? Well, that would be from 1 to 7. So 1, 2, 3, 4, 5, 6, 7. Now you might not need to fill all of those in. You could just kind of skip and do 1, 3, 5, 7, especially because we should recognize that all of your outputs are simply going to be, that's right, 5. Okay, so we're filling in 5s for all of these. And now if we think about opening versus closed circles, okay, when x is 1 with this interval, you can see we have a closed circle. And when x is 7, we also have a closed circle because it's 1 was less than or equal to x, which is less than or equal to 7. All right, so now we have to graph these. So let's start off by graphing the absolute value function on the left, okay, the top one here. And so I'm going to plot the point -3, 3 as a closed circle. Okay, then -2, 1. Oops. And we'll -1, -1. Then 0, -3. And then 1, -1 again. Oops, and that needs to be an open circle. So make sure I put that in as my open circle. Okay, so now we're going to connect these. Now we do not want arrows. -3, 3 was an endpoint, and this is your V-shaped graph. So it comes down and then V's back up. Okay, so there is the absolute value of 2x minus 3 over the interval -3 less than or equal to x less than 1. Now I pick up and I start with my next formula, which was just g of x equals 5 for the interval 1 to 7. So I'm going to go up to 5 when x is 1, and that's going to be a closed circle. So 1, and then up 1, 2, 3, 4, 5, and that's a closed circle there. And in fact, I go all the way across to 1, 7. So I'm just going to fill that, 7, 5. So when x is 7, 1, 2, 3, 4, 5, 6, 7, and then up to 5. And that will be another closed circle, and I'm just going to draw my horizontal line straight across there. And that is the end of my graph. There's no arrows at all on this, like I said, because we were given 2 closed intervals to graph. Okay, so we've just practiced 3 piecewise functions. I just want to recap. What are the most important steps? First, you need to make a table of values for each of the formulas that you're given, making sure to highlight the x's that you're being asked over on the interval side. Second, it is wise to take a second and mark when you have open versus closed circles or arrows on the end so that you know what you're doing when you get into your graph. Okay? And of course, then you're getting your y values from your table of values in your calculator for the given x's that you've already laid out for yourself. Lastly, you're going to your graph and you are graphing. You're being thoughtful of open versus closed circles and also arrows. Okay? What you'll notice on these guys is that they have to still be a function. They are called piecewise functions. What does that mean? Well, that means you cannot have one graph on top of the other. Do you see how this one is graphed and it stops right here? Just in time for this one to pick up right here and continue on. I couldn't have continued this any further because then it would be over top of this one, making it not a function any longer. So that's why it's exactly important that when one stops, the other one starts. Okay, let's move on to our real world example of piecewise functions. Okay, at an office supply store, if a customer purchases fewer than 10 pencils, the cost of each pencil is $1.75. If a customer purchases 10 or more pencils, the cost of each pencil is $1.25. Let C be a function for which C of x is the cost of purchasing x pencils, where x is a whole number. Okay, so C of x is equal to $1.75x if x is between 0 and 9. And isn't that what we said here? That when x is fewer than 10 pencils, when you purchase less than 10 pencils, you are paying $1.75 a pencil. But then there must be some special deal, okay, where if you purchase more than 10, you are now paying $1.25. Okay, and so we are going to follow this piecewise function that's already made for you. $1.75x between 0 and 9 pencils, $1.25x between when x is bigger than 10. Create a graph of C on the axis below. All right, so we're going to go ahead and do exactly what we've been doing all along. We're going to start off by making a table of values for each of these different formulas. So we have x, and we have 1.75x, and then we have x and 1.25x. So those are my 2 rules, my 2 formulas given to me. And okay, so now I need to go ahead and fill in my x values. Okay, in this situation, this is a little bit interesting, but they're telling you x is a whole number. That means we only are plotting our whole number values. So we actually do need to go ahead and fill in every whole number between 0 and 9. So this is kind of annoying, but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then x is bigger than 10. We can go ahead and fill in those values. Obviously, I can't go all the way to forever, so I'm just going to go 10, 11, 12, 13, 14, 15, and 16. And if I look at my graph, you can see that x goes out to 16, and so that's why I decided to stop there. All right, so now I'm going to go to my y equals and type in the $1.75x, so 1.75x, and go to my table, and I'm going to fill these values in. So I have 0, and then $1.75, then 3.5, 5.25. When x is 4, it's 7. 8.75 is the next one. 10.50. 12.25. Almost done. 8 is 14. And 9 is 15.75. Okay, now on to my second rule here. Just going to separate this. Okay, my second rule, I need to go back into my y equals and change it to 1.25x and copy down that table of values. And now I'm starting at 10 and going up from there. So when x is 10, it's 12.5 for my second rule, my second formula. 11 is 1375. 12 is 15. 13 is 1625. 17.5. 1875. And 20. Okay, now the idea here, and this is why they told you x is a whole number, is that you are only plotting these points, and you're plotting them all as solid dots. Why am I telling you that? Well, because if you connected them, it would indicate that you could buy a half of a pencil, and clearly that makes no sense. So we are plotting these points exactly as is. So as best you can, so 0, 0, 1, $1.75, so that's right underneath 2. 2 would be 3.50. 3 is 5 1/4. Oh wait, did I miss something there? No, 3 is 5 1/4. 4 is 7, so that's a nice whole number one. 5 is 8 3/4. 6 is 10 1/2. 7 is 12.25. 8 is 14. 9 is 15 3/4. Okay, so I have those points plotted all the way along. All right, and like I said, I know it seems weird, but you're going to leave those just as solid points. Because if I connected them, it would indicate that I could buy 1.5 pencils or 3.6 pencils, and you can't. That doesn't make any sense. So we leave those as solid dots. Okay, now I pick up and I have another graph, another rule to follow. So I'm going to do that in a different color, and I'm going to start that at 10, 12, 50. And again, these are solid dots. So 10, I start all the way up here at 12 1/2. So I make a solid dot there at 10, 12.5. Then 11 is 13.75. 12 is 15. 13 is 16 1/4. 14 is 17.50. Oops. 15 is 18 3/4. And 16 is 20, finally. And technically I really should have an arrow there indicating that it keeps going along that pattern. Okay, so again, I don't connect them because I do not have, I can't have in between 10 and 11 pencils. So that is my graph, and you can see the steepness of the purple dots is a little bit steeper than the green because our slope changes from 1.75 to 1.25. Okay, then there's a follow-up question underneath here. So the follow-up question basically asks, let's see here. A customer brings 8 pencils to the cashier and says, and the cashier suggests that the total cost to purchase 10 would be less expensive. State whether the cashier is correct or incorrect and justify your answer. Okay, well, if I have this table of values over here, I'm definitely going to use that to help justify my answer. So I'm going to look at my table of values. What was the cost for 8 pencils, and what is the cost to purchase 10 pencils? So I have these two values here, and I would definitely say that the cashier is correct. Cost for 8 is $14. And you could even show that by saying that's like, it's because it's $1.75. Oops, $1.75 times 8 is 14. Okay. Cost for 10 is $12.50. And again, where does that come from? $1.25 times 10 is $12.50. Okay, so the cashier is correct. And then justify your answer. I did. I explained why, because I said what the cost for 8 is and also what the cost for 10 is. And so definitely it would be a better deal for that person to just get 2 more and pay less money. All right, thank you so much for taking great notes and sticking with me. I know that this is tough to take notes like this and not have me be in front of the room, or maybe it's better. I'm not sure. But anyways, thanks so much. Your homework is the worksheet on piecewise functions, and you should be prepared for a small quiz next class. That would be on piecewise functions. Here, I'll write it down right here. Okay, so your quiz would be on piecewise functions. And also what we did last class. So average rate of change was the last class, as well as comparing functions. So comparing the linear, exponential, and quadratic. And the last thing we did last time was graphing different functions. So you should know how to graph absolute value. You should know how to graph square root, cubed root, cubic, all that. Okay? So just be prepared. It'll be a short quiz, and we will talk about step functions next class. Okay? Thanks so much. Have a great day, guys. See you next class.